In a monolith, one part of your code calls another by just calling a method. Same process, same memory, it trusts itself. But the moment you split that monolith into services, every one of those calls becomes a message over a network, and a network request can come from anywhere. So the first question of distributed systems isn't about speed or scale. It's about trust. When a request shows up at your service, claiming to be a certain user with certain permissions, should you believe it? Let's talk about trust boundaries. A trust boundary is a threat modeling idea, and it's simple. In a monolith, one process calls itself, so you check who the user is once at the front door, and everything behind it is trusted. Split that into services, and every call becomes a network hop. And now a request could come from your gateway, from another service, from a misconfigured client, or from an attacker who got a foothold. A trust boundary is exactly that line, the point where data crosses from something you control to something you don't. Splitting a monolith doesn't remove that line. It multiplies it, one boundary for every hop. Here's the mistake that sinks a lot of systems. The request arrived from inside our own network, from inside the cluster, so it must be safe, right? No. All it takes is one attacker with a foothold, one misrouted internal call, one buggy client with too much access, and inside means nothing. This is the whole idea behind zero trust. Never trust, always verify. Being on the right side of the firewall is not an identity. So every service verifies every request, at every boundary, not just once at the edge and then blindly trusting everything behind it. Perimeter security is a wall. You still lock the doors inside. So each service has to verify, but verify what exactly? There are 3 ways to carry a caller's identity across the boundary. 1. Pass-through. You forward the user's original token, and every service revalidates it against your identity provider. Simple, but now every service is coupled to that provider and its exact token format. 2. An internal token. The gateway verifies the user once, at the edge, then mints a fresh, short-lived token carrying just what downstream needs. And services trust one signer, the gateway, instead of the outside world. 3. On behalf of, where you exchange the token for a new, narrowly scoped one at each hop, precise, but chatty. Most teams reach for the internal token. It keeps each service simple and decoupled. Let's make it concrete. Here's our project tracker, split into services. I'll show it with Trellis, but the shape is universal. At the edge sits a gateway. It's the one place that talks to your real identity provider and authenticates the user. Behind it, 2 services, members and projects. The trust boundary is right there, between the gateway and each service. We're using Model 2, the internal token, so the gateway mints a short-lived token and each service trusts the gateway's signature rather than reaching back out to the user's identity provider. Members and projects don't know or care who your login provider is. They only need to trust one thing, the edge. And here's that boundary as real code, a downstream service, condensed from the template. 2 things are happening. First, the service sets its authority to the gateway. That means, discover the gateway's public keys and only accept tokens the gateway signed, for the audience that is me. Second, it hydrates the caller, the actor, with their identity and permissions from that internal token. Notice what's missing. There's no call out to the user's login provider anywhere in this service. It trusts the gateway signature and it rechecks that signature on every single request. That's a trust boundary, enforced in a handful of lines. So that's the foundation. Every time you split a system into services, you add a trust boundary, and the network itself is never one. Verify every request at every boundary, and pick a way for identity to cross it. We picked the internal token, authenticate once at the edge, then let each service trust the gateway signature. Next episode, we build the other half, the gateway itself, minting that short-lived internal token and handing every service exactly the identity it needs. Subscribe, and I'll see you there.